y is equal to 3x, y is equal to 2x squared 4x plus 3. What are these? These are obviously equations. Y is equal to x, y is equal to 3x, and so on. I can also say that is, as I change the value of x, the corresponding value of y is going to change. So all these, they are function of x. The value of y in each of these equations is very much dependent on the value of x. As you change the value of x, the value of y changes. And the value of y changes differently in all these three equations, because these three equations are different, they are different equations. So here y is a function of x. I can also write y is equal to c square plus 2c. Over here, y is a function of c. That is, the value of y is very much depending on the value of c. As we change the value of c, the value of y is going to change. Or we say that is y is a function of c. I say L is equal to 2k square plus 5k. Over here, I say L is a function of k. K is a variable. I will change the value of k. The value of L is going to change. So, this is a function. That is, L is a function of k, y is a function of c, y is a function of x, y is a function of x, and so on. I can also write y is equal to c2 square plus 8z cube plus 5. So over here, y is a function of c as well as z also. As we change the value of c and z, the value of y is going to change. So y is a function of c and z. In our day-to-day life, we have various options and choices that are available to us. Like, for instance, I can read a story from a book, or I can go to a cinema hall and watch a movie based on that story. So both ways, either I read that story or I watch the movie, I get the same kind of information from both the sources. Similarly over here, when I write equation y is equal to x, y is equal to x, it gives me some kind of information. That is, as I change the value of x, corresponding value of y is also changing. The same kind of information that can be pictorially, picture-wise, it can be expressed. The same information can be imparted like by a graph. I write over here, this side is x, this is y-axis. I write 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Over here, minus 1, minus 2. Similarly over here, minus 1, minus 2, and so on. If y is equal to x, this is a mathematical expression or equation. So what we have done in our earlier classes, if we intend to draw a graph of this, I say x, y. Put the value of x as 1, the value of y is 1. Put x value as 2, so this is also 2. When you put the value of x as 3, y is also 3. If you put x as minus 1, so y is also minus 1. I intend to plot a graph, so I take this pair of these points. 1, 1, x is 1, y is 1. I mark the point. 2, 2, x is 2, y is 2. I mark the point. 3, 3, x is 3, y is 3. I mark the point. Minus 1, minus 1. Minus 1, x is minus 1, y is also minus 1. So this quadrant. So I join this. So this line represents what? This line represents a function y is equal to x. That is, as x is changing, then what is the effect of y? So this expresses that. So this is something like reading a story, and this is pictorially, that is, you are watching a movie. Information is saying both ways. Now I'm interested in finding delta y by delta x. That is, I'm interested in finding delta y by delta x. That is, when the value of x changes by delta x, what is the corresponding change in delta y? Let's say I take this graph, this function only. Over here, this is 0, 0, 0 or 0, 0 coordinate in a plane. So if I take from here to here, what is the change in the value of x? Suppose I mark this point and this point, I take these 2 points. So from here to here, the value delta x changes like this. This is the change in delta x, that is delta x. This is change in the value of x. And constant change in value of y, this is stands for delta y. So So this is delta y. Obviously, same thing. So delta y is going to be 3 units and delta x 1, 2, 3. That is delta x is also equal to 3 units. So if I say, so this is delta y is equal to 3 units, delta x is also equal to 3 units. Delta y by delta x is equal to perpendicular by base in this right angle triangle. So if I take this angle as theta, perpendicular by base is what? Tan theta. This is obviously going to be 3 by 3, that is one and same, is going to be 1. 3 units by 3 units, that is going to be 1. So slope, tan theta is what's called slope. Tan theta is slope of the function in this case. And slope in this case is going to be 1. So tan theta, when we say that is delta y by delta x we are finding, we are primarily finding the slope of the function. You will agree that is if we have two mountains, something like this, and the other is like this. This is, I call it as a mountain A, this is mountain B. In which of the two cases, A or B, slope is more steep? Obviously, slope is more steep in this case as compared to this. It is more difficult to climb this mountain as compared to this, where the slope is very gradual. Over here, the slope is very steep. So I say the slope of A is much greater than the slope of B. Similarly, I can have a graph of two functions. One goes like this, I say A, the other is B. Which of the functions, A or B, which has a higher slope? Obviously, this seems more steep as compared to B. So, slope of A is greater than slope of B. Slope of A is greater than slope of B. Otherwise, if we wish to find out in terms of delta y by delta x, if we wish to interpret this slope in terms of this, how do we interpret? We interpret in a way, suppose I take that this is the value of delta x. So for this, I draw 2 points on this. I take these points. I take these points as alpha and beta. So when the value of x changes from here to here, what is the change in the value of y for function b? For function b, this is delta y. I call it as delta 1. When the value of x has changed, for this function from 0 to x, I take it as delta x. So what is the value of, what is the change in y? Over here, y was 0. Over here, this is something y. So this is delta y1. Whereas for this a, if I have to find out for the same change of x, that is from here to here, the y has changed from here to here. This is the change of y. So delta y1 for this, delta y2 is much bigger in case of function A as compared to B, whereas delta x, the change of value of x, has been same in both the functions. In this function also, we have taken the same change of delta x, whereas delta y is different. Delta y1 for this is this, and delta y2 for this is this much bigger. So I can say that is for A, that is delta y by delta x is greater than delta y1 by delta x for B. Or you can say the same thing, that is slope of A, delta y by delta x. What we have done? Delta y by delta x, that is a delta y by delta x is slope, we have taken it. So slope of this is more as compared to slope of this function. I can have function like y is equal to x, I can have y is equal to 3x also. So obviously over here, when x is 1, y is 1, x is 2, y is 2. Whereas over here, if x is 1, y becomes directly as 3, 3 into 1, 3. So if I draw these two, this is A, this is B. For the same change of x, there is change of y. Whereas over here, if you change the value of x, the value of y is 3 into change in x. The value of y is 3x. So as a result, if roughly I draw these two functions like this, so this b, this is going to be represented by b, whereas this is going to be represented by a, because the slope of this is less as compared to slope of this. because slope of this is less as compared to slope of this, that is delta y by delta x for this is going to be less, or delta y by delta x for this is going to be more. That is for the same change in the value of x, where the change of value of y is more, it is going to be like this. So slope of this is more, so that's why this is going to be represented by b, and this shall be represented comparatively by a. Let's say we have a function like this. So in this case, how to find delta y by delta x? You cannot say that is from here to here. Let's say this is delta x, so this is delta y, and we can find delta y by delta x. So it doesn't mean over here anything. Delta y by delta x will not mean anything over here. What we wish to find out, that you can see that is, if you are climbing this kind of mountain, so obviously you find that its slope is much steeper over here, then is gradual, then once again becomes steeper. Over here, you can talk of the slope, that is slope is varying throughout its length. Now, slope is varying throughout the function. Obviously, this is kind of function, mathematical function only that to represent. So, slope is changing throughout the function. So, what we do is, we find the slope at a point. At a point means what? At a point means, that is, I take a very, very small, short section of this length. Like, if I draw this circle, you will say this is an arc. But if I show you a very, very small portion of this arc, you will say that this is just a straight line. This is a straight line. Similarly, over here, I have taken a very, very small section of this length, so that this is almost a straight line. When you say this is almost a straight line, then this value of, and this is corresponding change which is said, this is called dx, and this corresponding change in the value of y will be called dy, and this will be almost a rectangle only. That is, this is a differential element of change in value of x, this is a differential element change in value of y. Differential, that is small change. Change is so small that is almost equal to 0 but not equal to 0. It is a very, very small length. This is, you are going to call as dx, this is going to be dy. That is, when you talk about delta y by delta x, and when delta x is tending towards 0, so you get dy by dx. This is you are doing much in detail in mathematics when you shall be doing limits. So, dy by dx is once again gives what? It gives slope of the function over there. It gives slope of the function only. Dy by dx gives the slope of the function. Dy by dx over here, it will have certain value, whereas over here, dy by dx, if I take a small section over here, slope is more, so dy by dx will be more over here as compared to this. We can also say, that is, we can find dy by dx for a point also. That is, point is almost, let's say, 0 thickness. So this is 0 thickness, or we can find the slope of the tangent at that point. That is one and the same thing. So when we are finding dy by dx, primarily we are finding the slope of the function at that point. Now when I write y is equal to x plus 5, and someone asks what is the value of dy by dx, so we are primarily interested in, that is, as there is change in the value of x, how there is a change in the value of y. That is dy by dx. That is, what is the slope of the function. The terms we use in this case when you write dy by dx, it is number one, you simplify it. It is simply asked, that is, find dy by dx. Second is differentiate y with respect to x. It's one and same thing. Either you say this or you do this. Or find derivative of y with respect to x. That is one and same thing. All these three things are the same thing. Now we are more interested how to apply differentiation in physics. How we can use differentiation in solving numericals in physics, etc. So without going much into the theory, we directly see that is what a formula which we shall be using. Now let's go directly to the formula which we shall be using and which will come handy in solving the numericals in physics or applying differentiation in physics. Y is equal to x raised to n. If y is equal to x raised to n, then dy by dx is equal to, n comes over here in front, x raised to n minus 1. Suppose y is constant. Let's say y is equal to 3. Then what is the value of dy by dx? So in this case, dy by dx is going to be 0. Why it is going to be 0? If I take this as x, this is y, I write 1, 2, 3. It says y is equal to 3. So it is going to be like this. So what value you change of the x, there will not be any change in the value of y. So this is a straight line. If you are going on a mountain, suppose you are moving on a structure like this. When you are going up from here to here, as the value of x is increasing, the value of y is also increasing. So from here to here, you say the slope is positive. When you go from here to here, this is straight line. Even if there is a change of value of x, the value of y is not changing, it remains same. So delta y by delta x, there is some change in the value of x from here to here, but the value of y doesn't change. So delta y by delta x is equal to 0, or even dy by dx is equal to 0. That is, slope is 0 for this. This is slope is 0. Over here the slope was positive. Over here it is 0. Now you are going downhill. As you are going downhill, even if the value of x is increasing, the value of y is decreasing, decreasing, decreasing. Over here the value of y is this, over here is this, over here is this. It is decreasing. Even if you go from here to here, as the value of y is increasing, but the value of x is decreasing. So for this section, the slope is going to be negative. So if I write something like, if I draw lines like this, so they will have a positive slope. If I write lines like this, they have a 0 slope. If I draw lines like this on this xy graph, this is xy graph. So if I take this like this, so even if the value of x is reducing, the value of y is increasing. For all these lines, the slope is negative slope. So for this, there is a negative slope. For this, is a positive slope. For this, the slope is equal to 0. So remember, that is, if y is constant, dy by dx is equal to 0. For a constant, derivative of constant is 0. Third is, if y is equal to x, then you can use the same formula. That is, dy by dx, I can write it as x is to 1, I can write x is to 1. So what happens? 1 comes down, x is a 1 minus 1, so it is 1x is 0, so that is going to 1, because x is 0 is going to 1. So if y is equal to x, dy by dx is equal to 1 only. Space, if y is equal to sin x, then dy by dx is equal to cos x. Y is equal to cos x, then dy by dx is equal to minus sin x. If y is equal to tan x, dy by dx is equal to secant square x. So these are some of the basic formulas. In addition to this, there is a one method, there is a one rule, that is what we call as chain rule, which will be really useful in solving the question. Now what is chain rule? Chain rule says dy by dx, dy by dz into dz by dx. The chain rule can also be written like dy by dx, if you to find out, this is dy by dz into dz by, let's say, dk into dk by dx. So finally, you will get dy by dx. Just for the convenience of remembrance, you can say this will go up, this will go up, and finally dy by dx will survive. It's just for the convenience of, that is how you can remember it.